Hey everyone, welcome back to another video in our Python tutorial series. In this video, we will be discussing unit testing. Unit testing is a level of software testing where individual parts of a software are tested. So unit testing is a great way to check if the code that has been written is functioning as expected. It can also help you check to see if any future changes break the code or have unintended consequences. So for example, if you update a particular function, you want to make sure that no other methods or functions were messed up, even though the newly updated function still might work. Unit testing is a necessity for large projects and is almost always used by major companies. And for example, the research that I am doing now at school requires unit testing for all of their components in their code base. So if you haven't used unit testing before, many of you have probably been testing your code using print statements, kind of like what I have down here below. However, testing your code this way isn't easy to automate and it's hard to maintain. So unit testing kind of addresses these issues. Again, if you're going to be publishing your code to GitHub or you're going to be sharing it to other people, you don't want to have these unnecessary print statements everywhere, and rather we would want to use unit testing. So right now on the left hand side of your screen, you will see a module with a couple of functions. This is in a file called example functions.py, and we have just written two functions, absolute value and square, where they return the absolute value of the inputted value and the square of the inputted value respectively. So in order to test these functions, we want to create a new module, preferably in the same directory, so that it's easier to import the module we want to test. And so on the right hand side of your screen, you will see an empty module, and so this is where I've already created a file, a Python file, and we're going to be using this to write our unit tests in. So in order to use unit tests or to make unit tests, we have to import the unit test module. This is already in Python standard library, so we do not have to add any third-party packages or anything like that. So we can do this by importing unit test like this, and next we also want to import the module we want to test. So in this case, we are going to be testing functions from our example functions module. So we're going to say from example functions, and we're just going to say import star. And this is just going to make it easier so we can call absolute value and square directly without specifying which module it is coming from. So now in order to create test cases, we need to create a test class that inherits from unit test.testCase. So we'll go ahead and create a class, and we're going to call it test example functions. So I'll say test, or class test example functions, and then this is inheriting from unit test.testCase. Now we're going to go ahead and write our first test method. Each test in this class is represented by a method, and each method must start with the word test. And this is required so that when we run the module, it knows what methods to run. So we're going to say define and say test underscore, and since we're going to be testing our absolute value method, we're going to say absolute value, and this takes in the parameter of self because this is in our class, and we're going to be using a method called Assert Equal in this case, and this method comes from our test case class, and I'm going to explain this in just a little bit. So we're going to just say absolute value of 2, and this should be 2. And so this method here, assert equal, takes in two parameters, let's call them x and y, and just is an assertion whether or not x equals y. And so I have the Python document opened up in a Chrome tab here, and if we read this little bit right here, it says the test case class provides several assert methods to check for and report failures. The following table lists the most commonly used methods. And in this case, we have used the assert equal. And all this does is just checks that A is equal to B. And so that's what we are doing with here. We're saying the return value of absolute value of 2 should be 2, and we are asserting this. So now let's try and run our method or our module. So if we go ahead and just save and run, you'll notice that nothing gets printed. And the reason why this is happening is because it doesn't know what test to call. In this module right now, all we have done is just define a class. Nothing is telling the interpreter or Python to run these tests. So in order to run these tests, there are two ways. The first way I'll show you is with using our terminal. So I'll just cd into where this file is really quickly. And next, what we're going to want to do in order to run this, we're just going to say python-m, right? So we're going to be running the unit test module, and now we have to specify the module that contains our tests. So for this example, it's going to be test example functions, right? That's the name of our module. Note that we are not including the .py extension here. So if we run this, we see this one dot, and so this dot means success or pass. This means a test case passed, and since we only have one right now, that just means our one test case passed. It says how many tests have run. So again, it's just one in this case, and it says how much time. And last, it prints out OK because we have passed all of our test cases. So it's kind of tedious to have to run using this command here. It would be nice if we could just do Python and then give it the name of the module, but as you can see, again, nothing is being printed because it doesn't know like what to run. So in order for us to have it be able to run like the second version, what we can do is add an if dunder name is equal to dunder main statement, and if this is true, we want to execute the main function of our unit test. So what this is doing, what these two lines of code is doing, is just saying if we are running the module directly, run everything inside of this conditional. And so inside of our conditional, we have unit test.main, and this will run all of the tests that are defined in this module. So now, if we open up our terminal again and try and run it the same way that we did before, now we see that we are now running the tests that we want to. And so now, because we can call it with Python and then the name of the module, that means now we can actually run it from inside our editor. So if I just save and run, we see that we can now run it like this, and this is consistent with the other videos that we have in our channel, and so we're going to be continuing like this and not running it from the command line for right now for the remainder of this video. Alright, so now we're going to just go ahead and add some more assertions to our first test case. Right now it's kind of bare, and it's not a good test case because we're only testing one possible input. Instead, we should test some edge cases, maybe some negative numbers, and make sure the output is what we expect. So I'm just going to copy this a couple more times and then just change the values here. So we expect the absolute value of 0 to be 0. We expect, let's give a float value, so we'll say 3.14. We expect that to be 3.14. And then now we should try a negative number. So we expect -1 to be the absolute value of -1 to be 1. And now we expect the absolute value of, let's say, -2.5 to be 2.5. So if we save and run, we see that we have, again, passed our one test case that we have in our module for right now. So let's suppose that we actually made a mistake, in our function. So what I've gone ahead and done here is just return just num, even if even if the inputted value is negative. So if we try and run our module now, we see that we have failed, right? And so what it tells us here is it gives us an F, right? So it says F, and it will print F if a particular test case fails, and it tells us which test case failed. So it's the only one that we have for right now, but it gives us the name of that method. So it's called test absolute value, and it tells us in what module this is in. And here our assertion error says that the absolute value of -1, which returned -1, does not equal 1. We know that our absolute value of -1 should be 1, but it's saying that the return value of our function returned -1. And notice how it also, instead of saying OK, now it says failed, and it gives us a number of test case failed. So we know that there's something wrong with our absolute value function, and so having test cases like this, where we know or in what we can expect, and have them be compared to the values that are returned from our functions, this can help us debug and find our error. So I'll just close out of this and make this to negative again, just so we know that this is right, and that's just showing you what it might look like if we have a failure. With our absolute value function that we have now, we would also want to test what happens if we pass in a value that isn't an integer or a float. So if we look at the code for the absolute value method, we see that the function raises a type error if the inputted value, so num in this case, because that's what we're calling our inputted value, if num is not an integer or float, we're going to just raise a type error. And so in order to make sure that a exception is raised when we insert a particular type of input, we can use the self.assert raises method here. And so I actually have the page pulled up for our for this method on our Python docs, and it gives a little bit of an explanation of what this is. So it takes in the exception that you're expecting, the callable, so that's the name of our method or the name of our function that we're testing, and it takes in whatever arguments you want to pass and any keyword arguments. So it says test that an exception is raised when callable is called with any positional or keyword arguments that are also passed to assert raises. So the way that we can use this is if we say self.assert raises, and we want to make sure that type error is raised. We want to make sure that a type error is raised in our absolute value function if we give the argument of, let's say, a string, and we'll call this string test. So if we save and run, we'll see that we get our successful test, and it is making sure that type error is being raised if absolute value is run with the argument of test. If we want to add another kind of keyword, or not keyword, argument, and test that, we can copy and paste that line, and we can give another kind of input. So this is with a list, save and run, and we see that we are still passing all of our test cases. Now, this is a fine way of using assert raises. However, if we go back to the Python docs, we can see that we can also use it with as a context manager. So using assert raises as a context manager, I find personally that it's a little bit easier because you don't have to write this self.assert raises with these 3 arguments arguments. It's not as clear, and I feel like the context manager is a lot clearer. So if we use this as a context manager, we'll say with self.assert raises, and now you just want to pass in the type of exception you're expecting. So here we're expecting a type error, and then we'll just have this be a underscore because we're not going to need this value. And now this is where we're going to call absolute value with invalid input types. So we'll say absolute value, right? And we'll say test. We can also call absolute value with our list like we did before. So 1, 2, 3. Whoops. 1, 2, 3. And let's even try to see what happens when we pass in a set. So say 1, 2, 3. If we save and run, we can see that we pass all of our assert statements that we have listed. So I think that's going to wrap things up for the test absolute value method. Now I want to write a test case for our square method. I've actually gone ahead and already wrote this one, and I'm just going to copy and paste it. You'll notice that it's very similar to the one above. However, there's two differences here in that I use assert almost equal when I am evaluating float values. And this is just because sometimes there can be a rounding error when working with float values, especially if you're dividing and multiplying them. So, for example, if I did assert equal, there could be a chance that the square of 0.2 might return a value of 0.040000 and maybe, I don't know, 6 or 7 zeros, and then it might have a 1, like 8 decimal places in. And so just to like avoid that, I just use almost equal. And so the rest is more or less the same. So if I say save and run, we'll see that we pass our two test cases. Notice that there are 2 dots here, meaning that we passed both of them. One thing I want to demonstrate now is that if I change the name of one of these test cases, so let's put A right in front, so A underscore test, you'll notice that if I save and run now, it says we only ran one test. And that's because, as I was saying before, each test must start with test underscore. Next, I'm going to just change this 9 to be a value of 8 just to see what it looks like when you fail a test and when you pass a test. So if we save and run, so we have one pass test indicated by the dot and one failed test indicated by the F. So we passed our absolute value test, but we failed our test square method. And it tells us where the error is, so it's on line 17, and there's an assertion error that 9 does not equal 8. And again, it'll say that we ran both of the tests, but the overall result of this test class is that we failed it because we had one failure. So I'm going to quickly change this back to 9. And now I kind of just want to switch gears a little bit because now we have seen how to add tests and make assertions and how to run the module. And now there are just some things that might especially be useful and I think it would be really helpful to review. So there are some special methods that we can use that might help us while we are setting up our tests. So the first method I'd like to talk about is the I'll define it, and it's called setup with a capital U. So notice that this is a camel case, takes in parameter of self, and for right now I'm just going to pass. So the setup method is called in order to prepare the test fixture. And so this is called immediately before each and every test method. So unless if we have an assertion error or we skip the test, any exception raised by this method will be considered an error rather than a test failure. So if I like just typed in gibberish here, right, and I run it, we'll see that we have 2 errors, right? We have EE. It doesn't say that we failed, but it'll say that we errored out because whatever I typed is not defined. And so again, what the setup method does is it is run every single time right before each test method. So one way that we can visualize this is I'll say print and then start of a method. I'll say test method. And then another thing that we can do here is I will print, we'll say test absolute method, and then I will copy paste this and I will print this down here, and I'll say this will be the square method, square, and this is test absolute value. Alright, so now if I save and run, we'll see that the string of start a test method will be printed every single time before the actual test method is run. So we'll see that we have start of a test method, and then we print. I just added this print statement to indicate that we're in a test, right? So it says test absolute value method. We have this dot, meaning that we passed it, and next we start our new method. And so before we start this new method, the setup method is called. So similarly, there's a method called teardown. So we have tear down, and again following camel case where the D is capitalized, and then it takes in the parameter self, and it does something really similar in that this will be called at the end of every test method. So if we say end of a test method, right? So now if we save and run, we'll see that we get our two strings to print out like we did before, right? So start of a test method, then we print that we're in the test method, and then the teardown function is called, and we print out end of a test method. So this is really helpful for when you might want to, when you have to, I don't know, create a couple objects every single time for every single test. Instead of having to write them down in the body of each test method over and over again, you can have one common setup for each one, for each method. So a use case for this might be if you are working with a database, you don't want to necessarily work with a table that contains the data that you want to keep. Instead, you might create a table for testing, and you want to make sure that this table is always in the right condition, I guess. So you don't want the table to be you don't want it to be filled with any data. You want it to be clean or something like that. So in your setup, you might create a table, and in your teardown, you might delete that table once that test method is done. So there are another two methods called setup class and teardown class. The setup class method is called before tests in an individual class are run, and the teardown class is a method that is called after the tests in an individual class are run. So what's important to note here is that when I write these two methods, these are not normal methods that you would find in another class. These are class methods. So that means we have to provide a class method decorator. So it'll be setup class following camel case, and then it'll take in this CLS parameter, and we have to provide that it is a class method, right? And so we'll say print, and in here I'm just going to say start of a class, right? And then in here we're going to do another one. This is a class method, and we want to define teardown class now. Teardown class takes in CLS as a parameter, and we're going to say print end of a class, right? So if we save and run, we'll notice that start of a class is only printed once, and this is at the very beginning, and that end of a class is printed at the very end when our test class is complete. Okay, so now that we've discussed the setup and set up class methods and teardown class methods, the last thing that I think that we should go over is how to skip a test. Sometimes we may need to skip a test because we know it's not ready yet, or because a certain test might be platform dependent. Maybe one test only works on Windows, and if we're on a Linux system and running the test case, we want to skip that test because it only works on Windows. So here I'm just going to show you how to generally skip over a test, and we'll be using a decorator here. So we will say @unit test and then .skip. And then in here we can provide a message, some kind of string that'll tell us why we're skipping. So for the purposes of this, I'm just going to write demonstrating skipping, save and run. So if we look at this, notice how now there is an S here, right? The red S indicates that we skipped a test, and the other methods and the other test functions and whatnot, they all run just as normal. They say, it still says ran 2 tests, however, one of them was skipped. We still get our OK printed, so our test suite did not fail. Another way that we can skip a test instead of using this decorator here is so we'll get rid of it, and you can actually skip within the test itself. So maybe there might be some kind of reason, some kind of conditional that we check, and if it's true, we might want to skip. So for the purposes of this, we're always gonna skip. So if true is always going to be true. So we're always gonna enter this block. So I'll say self.skipTest. And so now this is a method in our test case class. Again, we're inheriting from it. So the skip test is a method that's already defined for us. And in here, we can provide another message. So I'm going to say demonstrating skipping. And now I'm going to save and run. And the reason why I put this after our print statement, right, is because notice how our start of a test method, the test absolute value method, and end of a test method are all printed, right? Each of them is ran, except we still skip that test case. Alright, so that means that if you're in a test case, right, and you skip in the middle of it, whatever's the setup method and the teardown method will still run, and whatever's before that skip will also run in that test case. However, it's still gonna tell us that we're skipping, and it'll tell us that we skipped one, even though we ran both of our tests. Alright, and the last thing that I wanted to show you when it comes to skipping is that we can actually skip whole test classes. So I'm going to just take this out, and I will add our decorator to the class. So I'll say @unit test .skip, and provide a reason, and we'll say demonstrating skipping, save and run, and both tests in our test class here get skipped automatically, right? So it says ran 2 tests, both of which are skipped, and we still get our OK printed out. So I actually think that's going to wrap things up for this video tutorial. I know that things at the end got a little bit fast and maybe got a little bit confusing, so please feel free to leave questions and comments down in the comment section. I wanted to keep this video as short as possible, but I know that it's still pretty long and is definitely on the longer side compared to our other videos. So if you guys want to check out the code for yourself, feel free to check out the GitHub, and you guys can play around with it on your local machine. Other than that, I hope everyone is staying safe, and thanks for watching.